heat transfer, maybe every day we also feels this phenomena of heat transfer. Heat transfer is itself is a discipline of thermal engineering that concern about the generation, the use, and conversion and exchange of thermal energy. Especially we call the thermal energy as heat, and also it happens within the physical system. Just like in this room, we also feels about the heat phenomena in this room. If we maybe now we use air conditioning, so the air conditioning will help us to feel better, feel cool, and sometimes it will transfer heat from inside the classroom to the outside through this air conditioning system. That's why if we turn off the button of this air conditioning, maybe in sunny day we will feel so hot and we have to open all the windows so we will get some fresh air. This is also the phenomena of the heat transfer. And heat transfer, in this topic we will classify into some mechanism of heat transfer, like conduction, thermal conduction, thermal convection, and thermal radiation. So we will discuss about these three types of the mechanism of the thermal. For example, I believe that all of you like coffee. Maybe almost every day you drink coffee or tea. Sometimes you drink hot coffee or hot tea. Me also, every day I drink coffee, at least 1 cup a day, hot coffee. And I make myself, I don't like to buy a coffee shop because too much sugar for me. I don't like coffee with sugar. I like coffee with its original taste because the taste was helped me to keep awake and keep fresh all day. But sometimes my friends or my family ask me to go to coffee shop and they buy some coffee, but I think it's too many sugar. Even if I say to the bartender, please give me less sugar, I think it's still too sweet for me. So sometimes I refuse to add some sugar, even it's a small amount, because it's too sweet. So if you drink some hot drinks, for example coffee, tea, or any other drinks, so inside the mug or jar, if there is a hot coffee, so you will see at the first time when the bartender serves you the hot coffee, you will see that the surface of the mug or the cup is very hot. But if you keep it for a while, so the temperature or the thermal will be slowly decrease. After that, maybe you can drink easily. This phenomena also the example of the heat transfer. First, the cup of coffee was very hot. After several times, the temperature will be decreased and until similar or same with the environment temperature. So it will be stopped. Also, if you order some cold drink, iced coffee or iced tea or any kind of iced drink, for the first time the cup will be very cool. But if very cold, maybe you enjoy to drink that. But if very hot, maybe it's you will not enjoy. And also, if you keep for a while, the ice cold will be slowly melting, and then in several times the temperature will be also similar like the environmental temperature. So it is also the example of the heat transfer, but different transfer direction, heat transfer direction. For the for the hot coffee or hot drink, the transfer direction, heat transfer direction was originally from the hot coffee to the environment. So the environment will be receive some amount of the heat from the coffee, hot coffee. But contrary with the cool drink, so the drink will receive some amount of heat from the environment. So both of them will be stop and stay in a similar or same temperature. So the temperature will be stopped to transfer heat when both of them was in a similar temperature. So if you go to mountain, because mountain was very high land and the temperature was sometimes drop. So when you go hiking on the mountain, maybe for the first time when you're moving, your body feels warm and hot. But when you already in the top of mountain and you stay for a while, you sit down, or maybe you sleeping, and your body get colder than before, because your body was receive the heat from the environment. Because the environment in mountain, there has a big potential energy than your body. So your body will release the heat, and then your body will be same temperature with the environment. But if you still alive and your lung and your heart still beating, your blood will be circulated, your temperature warming to hold your body, so you will keep warmer. But if you maybe stay for a long time not doing anything, your blood circulation will be slowly decreased, and also your body warmth will be slowly decreased. That's why if you go to mountain, you must wear a good jacket to keep your body warm, not go outside easily. If you just wearing maybe like normal clothes, you will get very cold, because your body is easy to go outside. Your warmer body is easily to go outside, and it will be danger for you. And then the application of the heat transfer in nowadays, there are so many application of heat transfer. Yes, please. For example, in architecture area, there is some tools or machine that operate using the principle of heat transfer. For example, smart meter. This is an electronic device that can measure and record the electric energy consumption based on the heat transfer. And also thermal transmit. Also maybe some room like this. This is the application of heat transfer tools in our daily life. Basically, the concept of the air conditioning is not changing the oxygen inside this room. The oxygen inside this room was stay or remain not move anywhere. Especially if you close all the door, all the window, so the oxygen will be stay in this room. But the air conditioning only take the heat, not the oxygen. So this air conditioner only take the heat, but the oxygen still remain in this room. So if you in your house or in your room maybe using air conditioning, so I suggest every day you must open your door or window to keep the air circulation in a everyday change into fresh air. Because if you not open the window or door, the air was not circulated and it will stay inside this room. So air conditioning only take the heat from inside this room and transfer into the outside. And as usually air conditioning for housing, they have two sides. The inside room it was called evaporator, and the outside room there was also some big bulb there they call as a condenser. So the evaporator will take all the heat in this area, and the heat in this area was taken by the fluid, usually using freon, and the freon will be transferred into the outside. And after the freon inside the condenser will be blow the heat outside. So if you stay in front of the condenser and the air conditioning was turned on, you will feel the hot blow air from the outside of the condenser. It means that this heat inside the room was transferred into the outside. And if the air conditioning is still working, they will continue to take the heat from this room, because the heat was taken outside, so the temperature in this room will be decreased because the heat was transferred into outside the room. After you set up the temperature, if you set up the temperature, for example, 21 degrees Celsius, and if this temperature already in 21 degrees Celsius, so the system mechanism will stop. If air conditioning will stop to take the heat. But when the temperature decrease, for example 21.5, the air conditioner will be on and take the heat. So this will operate simultaneously. It will keep the air temperature stay in your setup. So if you not set up the temperature, so the heat will be pushed outside. So this room will be decreased. The temperature will be decreased. For example, if you have some refrigerator, freezer temperature can drop until 0 and more, maybe -1 or -3 inside the refrigerator, because it continue to take heat inside the refrigerator room, go to outside until the temperature drop. That's why if you make if you take some water inside the refrigerator, especially in a freezer room, the water temperature will be dropped until zero and it will become ice. But the system was proven not dropped. Maybe this for air conditioning, maybe the lowest temperature maybe only 80 maybe for normal air conditioning. The other application also for the plantation, for example for greenhouse. Greenhouse was especially greenhouse using to plant some plant which it need hot condition like in tropical climate. So the greenhouse will have to keep the temperature inside the room is similar like a tropical temperature. Like in Indonesia, this is also tropical climate. Maybe every year the temperature was range from 23 until maybe 30. This is the tropical temperature, and some plants need the temperature to keep growing. So the greenhouse keep to protect temperature not drop, and it will warmer inside the greenhouse. Many times I go to greenhouse. For example, in Brawijaya we have some greenhouse building, maybe near the agriculture faculty. There is some big greenhouse. I ever go inside and I feel warm, hot, maybe hot inside the greenhouse. But some plants was easily to grow in that temperature. And also there is so many machine or tools that operate using a heat transfer, like oven or toaster. If you every day maybe making bread or cooking some chicken, roasting chicken and using oven, it is also tools using a heat transfer. Also in farming, in a greenhouse will keep the temperature stable in specific range of temperature. The other tools was called a heat exchanger. Actually, air conditioning, this is also the example of heat exchanger. But the purpose of the air conditioning is to cooling the temperature. But in industrial, there is some need to get some hot air using the heat exchanger. For example, to moving the turbine, and sometimes for moving the pressure vessel, keep the pressure vessel, storage the high temperature water, for example. They are using a heat exchanger. So the heat exchanger will be produce some hot air, but sometimes we also can convert or reverse the system. For example, this air conditioning also the example of heat exchanger, but the purpose is to cooling down the room temperature. The other is boiler. So boiler is the main machine in the first industrial evolution. In first industrial evolution, boiler is the main source of the moving mechanism. For example, to get some energy from the hot water, and the hot water will be produce the hot air, and the hot air can help to moving any kind of big machinery like a train. In the early years, in the first industrial evolution, many train was moving using by boiler system. So we have to bring some coal or some wood, dry wood, to make a fire, and the fire is to heating some water, and the hot water, they have a high pressure, and the high pressure was using to moving the piston of the train, so the train can move. Until right now, some boiler was also using in a big company, usually to produce some heat water production for the turbine, for some the pressure vessel, also using the boiler. In a big company, maybe the size of the boiler was very big. Usually for the power plant, for generate electricity, they also using the boiler. In Indonesia, also some power plant was using boiler system. For example, near here, maybe at Python. Do you know Python? Probably no. In Python, there are some big power plant. The system of power plant using also boiler, and the source of the energy using coal from mining. So the coal was burned, and the fire was using to heat up the boiler, and the hot pressure and from the boiler was transferred to the turbine, and the turbine was rotation, and the rotation of the turbine using to moving the generator, and the generator can produce the electricity for human daily life. I ever go to probably no power plant Python, and I see that the boiler construction, it has height maybe seven or 8 floors. This is for the boiler system. So the preheat, the second preheat until the main heat. After that, the main heat was transferred into the turbine, and the system was the height. It's about maybe 7 or 8 floors. So it's very big company or plant to produce the electricity from the boiler system. The other example is water heater. Maybe in your house, maybe you're using this system to produce hot water for your daily activity. Every day, if you take a bath using some nice warm water, you will use these things. Then we go to the classification of heat transfer. Today we will discuss about 3 types of heat transfer. First is convection, second is convection, and the third is radiation. We go first to the first heat transfer. We call as convection. In Indonesia, maybe we say as konduksi. In Indonesia, I think it's in English we use conduction. Conduction, actually, this is also the first form of the heat transfer. If we take a look in a microscopic scale, yeah, the heat conduction occurs in a level of atom or molecule inside the material. For example, if you have a bar of the iron, and in one end of your bar you take some fire and you burning in one end of bar, and the other was keep cooling, same temperature with the environment. So if you keep burning the end of the bar, after several times the heat was transferred into the whole body of the iron. In the first time, maybe if you just lighting the fire for the first time, maybe your hand still can hold the bar, but after several times the bar you're holding will be kept warmer until maybe your hand cannot barely to touch directly into the iron. This is the phenomena of conduction. And the conduction actually happens in the microscopic scale. We can see that small circle, it is the small molecule or small atom. So if you burning the light, basically you give the energy, internal shape into the bar. So if you give the energy into the bar, so all the molecule will receive all the heat energy. And if the heat energy level was higher, so the molecule inside this iron bar will easily to moving. Especially electron is easily to moving from one atom to another atom. When you increase the temperature, so while the excitation energy of all the atom or molecule higher, it will transfer into the next atom beside the atom. Then all the atom will also receive and absorb all the same energy. That's why if you burning lighter in one end of your iron bar, at the last time, and you will feel that the other side of the bar also the temperature will be increased. This is the phenomena of the conduction. In conduction, we can see that the bar, the area of bar, this is the area of bar. So this is the cross-section area of the bar. So if the bar was shaped like a circle, so the cross-section area was the area of the circle. But in this example, the area was in rectangular. So the area, you can calculate how many the area of rectangle. And D is the distance or thickness of this bar. T1 is temperature at point 1, T2 is temperature at point 2. And the temperature difference was delta T. And from the conduction, we can see the heat transfer. It will transfer from the hot part or hot condition into the cold part. So this is the basic direction of heat flow. So the heat flow will be flow from the hot to the cold part. And conduction, mostly we can see in almost all types of metal. So almost all type of metal we can say as a good conductor. And contrarily, there are also some material that was difficult to transfer the heat into the from its surface. We call as an isolator. The example of isolator, for example, is wood, rubber, plastic, water, glass, and any other polymer material. It's isolator. So basically in conduction we will know two types of material. First is conductor material and the second is isolator material. Just like this table, this is a good isolator, but this is very bad conductor. And like this cable, inside the cable, the core of the cable may be using the chopper, maybe mix chopper, iron, and any kind of metal. So inside this cable, this is a good conductor. But the outside, this is some polymer to keep the electricity still transferred inside the cable, but it's keep safe for human daily life because this is the isolator. Maybe this is using rubber or some type of polymer. So when you're using the cable and the electricity was flowing inside this cable, we can easily hand this cable without get some shock because the outside surface was covering by the isolator. And in conduction, we can calculate how much the conduction rate. The equation of conduction rate was Q per T. Q is calor. Q divided by T. T is calor. T is temperature. Q is time. So the unit of the conduction rate, E was calor, the unit of calor was joule, and T is time, the unit of time is second. This is second. So the equation of Q per T was equal to Q multiplied by A. K is thermal conductivity of any kind of substance. Every material in this earth has a specific thermal conductivity. A is the cross-section area. Delta T is thermal difference divided by D. D is thickness of the material or the distance of the material. This is the equation to calculate the conduction rate. For example, if I have two different thickness of the same material, this one thickness is 1 inch and this one is 2 inch. And then below the material, I take some burner and I lighten the burner to burn the low surface of these two material. And the question is, can you guess which material is easy to get hot between A and B? Which material is easy to get hot? according to the equation of the conduction. Can you guess which one, A or B? A? Why?
Because like top part is thinner, so like it's easily to spread.
Yeah, you're right. Because the thickness at A part is 1 inch and the B part is 2 inch. It means that A part is thinner than B part. According to the equation, conduction rate Q plus D. So if D is smaller, so the conduction rate will be higher. And contrary, if the D is bigger, so the conduction rate will be also smaller. That's why A part is easily to get hot compared with B part. If A and B part was made from the same material. So if you like cooking every day, maybe you're cooking, if you're using the thick pan or using the thinner pan, it's easily, if you boil some water, the water is easily to boil if you're using the thinner pan compared if you're using the thicker pan. So you will need more energy to boil some water if you're using thicker thickness of pan. And second condition, I have two type of bar. A bar is shorter than B, and in one side I give some lighter into the one end of the bar. So can you guess which part is faster to increase the temperature if we measure at the end of the other parts? Which one is faster to increase the temperature? A or B?
A.
What?
A.
A. Why?
The thickness is small and smaller than B.
Because the distance,
Yes.
the distance is smaller than B part. So for B part, you need higher energy to get all the body to get warmer. But in A part, you need smaller energy compared to B part because the distance was shorter. A part distance was shorter than B part. And the next example, I have two type of the material. Both of them was metal. In the figure 1, these two material has different temperature, and both of them was contacted each other. Both of them was contacted each other. The A part was 40 degrees Celsius. The B part was 140 degrees Celsius. And in figure 2, I have the A part was 35 degrees Celsius and the B part was 185 degrees Celsius. And both of them also contacted each other. So based on these two figures, can you guess which figure is have the higher heat transfer? Which one?
The second one.
figure 2?
Yes.
Okay, why?
Because it transfer at a high amount from 185. The different change is a lot.
Yeah. The different temperature was higher at the figure 2. Yeah. From 185 to 35 degrees. So it's around 150. And this is from 140 to 40 degrees Celsius. It's around 100 degrees Celsius. So based on the equation, this is the delta T or thermal difference. So if the thermal difference higher, so the conduction rate also higher. But if the thermal difference was lower, also the conduction rate also lower. So based on the equation, we can guess which one has the higher conduction rate. Okay, next we go to the calculation example. I have a glass, and the glass was filled by some water, and also I have a spatula, and spatula using to mix the water inside the glass. And inside the glass, and the temperature was 500 degrees Celsius, and the length of spatula is 0.25 meter. 0.25 meters. And the surface area is surface area of the spatula. This is. So the area of the spatula is, this is the spatula. The area surface is 2 multiplied by 10 by minus 3 meter square. If the other end of the spatula was in a room temperature, it means that inside the glass there is some liquid, and the temperature of liquid is 500 degrees Celsius. Oh, it's very hot. So maybe this is the iron liquid. And the outside was in room temperature. It means that this part of the spatula was in a room, same with the room temperature, which is the room temperature is about 200 degrees Celsius. Maybe because the liquid was very hot, so the temperature near the glass is also higher. It's around 200 degrees Celsius. Calculate the amount of heat flowing along the road, along this spatula, for 5 minutes. How many heat transfer flowing into the spatula for 5 minutes. And in this case, the thermal conductivity of glass is 0.8 watt per meter Kelvin. Then we it means that 50 and this is a 20. I made a mistake. Sorry. I will change the pictures. This is of the spatula is 0.25 meter, and the surface area of the spatula was 2 multiplied by 10 by minus 3 meter square. And the temperature at the end of the spatula will be similar with the room temperature. It's around 20 degrees Celsius. And time for heat flowing is 5 minutes or equal to 300 seconds. And the conductivity thermal of the spatula, usually spatula was made from glass, sometimes wood, sometimes glass, or sometimes using a plastic. And the spatula was made from glass. And the thermal conductivity of glass was equal to 0.8 watt per meter cube. So, using this equation, we can get the Q per T was equal to K multiplied by A multiplied by delta T divided by D. Q per T was 300 seconds. The time was 300 seconds equal to, this is the thermal conductivity of the spatula multiplied by cross section area and multiplied by thermal difference. It was 50 minus 20 and divided by the length of the spatula is 0.25 meter. So, based on this equation, we will get the amount of the color flowing from the glass to the spatula for 5 minutes will be equal to 0.192 multiplied by 300 was equal by 57.6 joule. So in 5 minutes, there is some color 57.6 joule was flowing and was transferred from the glass to the spatula in 5 minutes. And then this is some example of thermal conductivity of some material. For example, for metal, like aluminum, the thermal conductivity was 205.0, brass was 109, copper 300, silver 400, around 400. We can see in metals, maybe silver is the highest thermal conductivity. Iron is 7.3. So silver and copper is they has the high thermal conductivity. That's why silver and copper sometimes is good for conductor tools. For example, like cable. Sometimes the core of the cable was using copper or silver, but maybe silver is very expensive for using as a core of cable. So the good one is copper, because silver maybe is very expensive. So the price of the cable using silver may be very high. And the other example is like a glass wool, concrete, PVC, cellulose, and any type of material. If we compare, this is the metal group, this is gas, and this is some kind of polymer like glass wool, rock wool, and this is from polymer. Concrete is like this wall, concrete. We can compare the thermal conductivity compare with the metal, and so the thermal conductivity of the non-metal material is lower, if we see the metal, the thermal conductivity is higher. This is tree, oak tree, maple stone, granite. So if you want to choose some material to reduce some heat, you can choose material from non-metal material. For example, glass wool, using to cover or to shield the high temperature condition, sometimes inside the oven. So the electric device inside the oven keep safe because was covering by glass wool or rock wool. And also sometimes glass wool and rock wool using in automotive parts, like inside the exhaust system. So inside the exhaust system, to protect the surface of the exhaust not too hot, sometimes the inside liner of the exhaust was covering using the glass wool or rock wool. So it will prevent the surface of the exhaust system. But sometimes it's still hot. So you cannot touch your exhaust system after you using your car or your motorcycle because it is very hot. But using the glass wool and rock wool, the temperature, we can shield the hot temperature, so it's not too hot. So if you want to lower the temperature of your exhaust system, you can buy some glass wool or rock wool, and you can add in more glass wool inside your exhaust system, so it will make your motorcycle or car exhaust temperature will be warmer, and sometimes it's safe to touch it. Then we go to the second heat transfer classification. The second one is convection. In Indonesian language, we call it as konveksi. The convection is also the other form of heat transfer. But convection heat transfer was happen in a different material. For example, in the picture, you can see that there is a glass or a pan, and you filling the glass with the water, and you take your glass filling with water, and you give some fire or burner under the glass, and you lighting the burner. This is like you boil the water on the stove. So at the first time, the fire will be burned under the surface of the glass or the pan. And the first time, maybe the temperature of the water maybe will be similar like the environmental temperature. But after several times, you keep turning the burner or the stove, then slowly the temperature of the water was rise until you can see that the water surface will be boil up, and you can see some hot bubble comes from the water. It means that the temperature of the water was rise high until, if it is at the boil temperature, maybe until 100 degrees Celsius. This is the phenomena of the convection. We can see that the source of the fire was touching at the surface of the glass, not touching directly to the water. So the source of fire originally touching only the glass, not directly into the water. But after several times, the temperature of the water also rise up. It means that in this case, it happened heat transfer, and we call the type of the heat transfer is convection. So we can easily to say that convection is the transfer heat from one place to another place due to the movement of fluid. This is the simple definition of the convection. And this condition, the convection, sometimes we can force the movement of fluid. Sometimes it happens naturally. Sometimes convection also happens naturally. And then in convection, we can also calculate the convection rate. If we see the equation of convection rate actually almost similar with the conduction rate. Convection rate also using the same symbol, Q per T. Q is calor, T is time. But the equal was different. The difference is only in this constanta using H. In conduction using K. This is the thermal conduction. But in convection using H. It means that the convection coefficient. The other is similar. This is the cross-section area and this is the temperature difference. So the convection rate and the conduction rate equation was almost similar, except the coefficient. And in convection, there are some various types of convection. The first is free convection or natural convection. Second is heat transfer is caused by difference in temperature and density only, and there is no external force pushing it. So the heat transfer happens because there is a difference in temperature and density of the material. The example is a hot plate is left in the surrounding air without any external force of movement. So the convection also happens in a hot plate. And the other type is forced convection. The heat transfer of a gas or liquid flow caused by external force. Example, a hot plate is blown by air with a fan or blower. So if you want to decrease the temperature of your drink or meal, you can take some fan or blower and you turn on the blower, and the blower will speed up the convection rate of your meals or your drink. But if you turn off the blower or fan, so the convection rate will be back to normal according to the difference of the temperature between the environment temperature and your drink or meals temperature. So by adding the blower or fan, this is the forced convection. in our daily life, we also using the concept of the forced convection. For example, if you using usually in car, in motorcycle, maybe some motorcycle also using this part, but some others not using. In car, there is some device to reduce the temperature of your engine machine, because the engine machine was produce heat, so you need to cool down the system. So there is some cooling device in your car. It's called a radiator. So the radiator will help your car to keep the temperature in a specific temperature. It also help your car prevent damage because overheating inside the combustion chamber. And if you see the radiator, there is some part of the radiator. There is a big box with a thin, fine. So the hot water was flowing inside the thin fine, and the other is some blower. So the blower will help to cool down the water flowing inside the radiator fin. It will blow the heat comes out from the radiator. Especially if your car was moving, there is two types of the blower. First is blow by the fan, and the second was blow by the movement of your car. Because if your car was moving, there is some air from the front side of your car. But if there is a traffic jam, so your car was stopped, but your engine car still running, so there is only one device to blowing. There is a blower or fan to blow the hot water temperature from the inside of the radiator. If the fan or the blower was broken, so the temperature inside the radiator was high, and it's danger for your car. You have to shut down your car, turn off your car, and wait for a while to get the water temperature inside the radiator was decreased. If you keep driving and your blower or fan was broken, and then your car will be overheating, and it will danger for your car. Your engine can blow up, and it's very dangerous. So maybe 2 or 3 days daily, before I using my car, I always check the coolant. Is there some coolant inside the reservoir or not? If the coolant was only a little, so I have to adding some water coolant. And also I check the fan or blower operation. It is normal or no? Maybe the rotation of the fan, maybe if the fan was old, sometimes the rotation was slow, so the rate of the convection will be slower. And if it is happen, you have to change the blower or the fan. Many times I change myself for my car. Change my blower. Usually there is normally two fan or two blower inside near your car radiator. And also some motorcycle right now using also small radiator and also some blower. I have two type of motorcycle, one not using radiator and the other using radiator, using a liquid cooler. So if your car or motorcycle have a cooling system, please daily check the level of coolant. Sometimes the coolant was little, so you can put and add some additional coolant. Okay, we go to the second example of convection calculation. The temperature of a person's skin, our skin, yeah. Without clothes, it's approximately, I made a mistake. Why? Maybe human body's temperature maybe around 32 degrees Celsius normally. But sometimes lower, but sometimes also higher. If you get some cold, you get some fever, maybe your body's temperature will be rise. So you need to cooling your body's temperature. Sometimes take a bath, it's using a warm water, it will help your body to cool down temperature. Or sometimes you will using some wet towel, touching your chin, in your head, it will help to decrease the temperature of your chin or head. If the person is in a room with a temperature of 22 degrees Celsius and the body surface area is around 1.6 meters square, how much heat does a person's body release through conduction? Because your body produces heat continuously, so the heat will be flow from your body into the environment. And conduction rate of the human's body is around 7.1 joule per second. And according to this information, we can calculate the convection rate. So the convection rate for, this is also 5 minutes. 5 minutes from the human's body into the environment was equal to 3408 joule or equal to 34 kilojoule in 5 minutes. So human body also has a mechanism for heating your body, but not too high, in a specific temperature, maybe around normal human, maybe the heat body temperature is around 32 degrees Celsius. But if you take exercise like a running or any other exercise, maybe your heat temperature was slightly increased, maybe 35 degrees Celsius if you do some exercise. Okay. Then we go to the last heat transfer classification. We call as a radiation. Thermal radiation is an electromagnetic form, energy form, transfer. Why we call it as an electromagnetic radiation? Because the heat transfer was flowing without any substance to transfer the heat. That's why we call it as an electromagnetic. And the electromagnetic is the form of energy. For example, sunrise, the heat of sun will comes to earth. It's not need substance to bring the heat from sun to our earth, because the sun rises and the light of the sun was transferred into everywhere without using substance, because it is a form of the electromagnetic wave. So the electromagnetic wave bring some specific of energy. That's why in heat transfer we call it as a radiation. And in our galaxy, the source of the heat mainly comes from the sunrise. The second comes from if in Earth, comes from the core of the Earth. The core of the Earth until right now, there is still hot, because the Earth still moving, and because the early formation of the Earth comes from the very hot things, and now after 1,000 or more million years, the temperature of the Earth was decreased until now we can live in the Earth's surface nicely, because the temperature of the Earth was very much decreased. But inside the Earth, the core of the Earth is still very hot. That's why in some volcanoes eruption, mountain eruption, the core of the Earth comes out in a form of a liquid shape. We call it as a magma or gas, hot gas, sometimes a hot gas, or lava, magma of lava. So in a volcano eruption, these two things is very dangerous. The lava is very dangerous because the temperature was extremely high, and also the hot gas is also very high. And because the hot gas density was higher than oxygen density, that's why if the hot gas comes from the eruption, the hot gas will not goes outside, but it will goes under into the surface of the earth. And sometimes if the hot gas hit many living things like plants, animal, human, it's destroyed all the way it passing. So it's also dangerous. Maybe in Malang, which mountain is still active near Malang? Which mountain? Maybe Semeru. The highest mountain in East Java, maybe Semeru is still active. Also, this mountain is Arjuna, maybe Arjuna mountain. But Arjuna maybe long time never eruption. But maybe Arjuna is still in radiation. We can calculate the radiation rate, and the equation of the radiation rate was different. compared with conduction and convection. The radiation rate Q per T equal to E was emissivity coefficient, and the value of the emissivity coefficient was ranged between 0 until 1, but not equal to 0, also not equal to 1, but range from 0 to 9, so 0 point something else. And the alpha is the Stefan-Boltzmann coefficient, and the value of Stefan-Boltzmann coefficient was equal to 5.67 multiplied by 10 by minus 8 watt per meter square Kelvin by 0.4, and multiplied by E and T. T is absolute thermal. For example of the radiation is sun rays. So when the sun rise comes to the earth, because in the atmosphere of the earth there's so many gases, but outside the atmosphere of the earth there is no gases, or the environment was in a vacuum condition. There is no air outside the atmosphere of the earth, so all the gas was inside the atmosphere of the earth. But sunrise, still the energy of the sunrise still can reaching the surface of the earth, because there is a radiation using electromagnetic energy. And when the sunrise goes to the earth, there sometimes the sunrise was absorbed by the clouds, also absorbed by the layer of the atmosphere. So the plus of the energy of the sunrise reached to the earth was so many degrees. If there is no layer of the atmosphere, there is no clouds, so the thermal energy received by the earth's surface was so much higher. So that's why the atmosphere was protect the earth from the overheat energy from the sunrise. That's why now we also concerned about the layer of the atmosphere, because the human activity, we produce many harms gas, harms material, and some gas was sometimes broken the chains of the layer atmosphere. So if some area of the layer atmosphere was missing, it means that there is no layer. We call it as a hole at the atmosphere. So the sunrise comes to the earth without any protection. For example, some form of the electromagnetic wave is UV electromagnetic. And UV has three types of wave, and only one is using by the living things, like a plant to get some photosynthesis. They need a UV type A, but UV type B and C is very dangerous. Usually UV type B and C was absorbed by the layer of the atmosphere. So if the layer of the atmosphere was missing, so the UV type B and C was not absorbed, and if directly comes to our body, it will dangerous to our body because it can broken and it can cause some disease like skin cancer if we directly get some UV type B or C to our skin. It's danger for human life and also any living things, not only human. That's why now human also concerned about the layer of the atmosphere. We have to reduce the production of the exhaust system from industrial, from automotive, for car. If we can produce less exhaust gas, so it will preserve the layer and thickness of the atmosphere. It will help human can stay longer in surface of the earth. Okay, we go to the calculation example of the radiation. A thin square steel plate with a side length of 10 cm is heated in a furnace until the temperature reaches 727 degrees Celsius. 700 degrees Celsius maybe for the metal, for example iron, is not yet melting because the melting temperature of iron is around 1200 for iron, but any other metal is different. For metal, maybe it's not yet reached the melting temperature 727 degrees, but maybe the surface of the metal will be in a red color maybe, if reaching 700. And if the steel plate has an emissivity of 0.9, what is the radiant heat rate? Also the radiation not only produced by the sunrise, also produced by this example. For example, if you have an iron, you heat the iron inside the furnace until the iron was in a red color, and then if you take out the iron and you put in some place, maybe your skin, you can feel the hot from the radiation of this red iron. Maybe you can feel your skin without touching the red iron, because there is some radiation or some radiant energy comes out from the hot material. In this case, we also can calculate the radiation rate of the hot iron using the calculation of the radiation. Q per T was equal to E multiplied by alpha multiplied by A and T by 4 times. So according to this information and data, we can get the radiation rate was equal to 510.3 joule per second. So per second was there is some energy equal to 510 joule per second. So if you stay for a while near the hot material, so your body was receive some amount of the heat radiation in a thermal radiation. Okay, then in this slide I have two tasks for you to calculate as a homework. I have two. This is the first task and this is the second task. Please do your homework and submit your homework to my locker. Yeah. In fourth floor. Yeah. Please put inside my locker. And together. Yeah.
Okay.
Together. So in all the students submit in one bundle. Submit in one bundle and store in my locker. Okay, I think that's all for